Hello students! Are you ready to dive into a world where chemistry meets biology? Today, we unravel the intriguing tale of a vital mineral, iron. Iron serves several critical functions in our bodies. It binds with oxygen and carries it from the lungs to every corner of our bodies. This oxygen is fundamental for producing energy. Additionally, iron is part of myoglobin, a protein that stores oxygen in muscles, prepping them for physical activity. It also plays a role in cellular respiration, an essential process that happens at the cellular level, transforming nutrients into usable energy. Now, what happens if there's not enough iron in our body? Iron deficiency can cause a drop in hemoglobin levels, leading to a condition called iron deficiency anemia. With insufficient hemoglobin, our tissues receive less oxygen, triggering symptoms such as fatigue, breathlessness, palpitations, and brittle nails. The flip side is also concerning. Consuming too much iron could lead to siderosis, a condition in which iron stores become overloaded. The dietary reference values, or DRVs, for iron take these potential issues into account. They acknowledge that only about 15% of iron from a mixed diet gets absorbed by our bodies. Hence, different groups might need different iron intake. For instance, women of childbearing age often require more to compensate for the iron loss during menstruation. Where do we get this essential mineral? About 2/3 of dietary iron comes from plant sources, especially cereals and bread. Meat, particularly organ meats, and vegetables, are also excellent sources of iron. Yet, the iron we consume doesn't just glide into our bloodstream. It has to pass through several checks and balances, with only about 10% of the iron making the final cut. This absorption mainly happens in the small intestine. Various factors, including phytates in food and dietary fibers, can hinder this process. Our bodies employ two mechanisms to absorb iron. Ferric iron, the non-absorbable type, must first be converted into ferrous iron, the type our bodies can use. This conversion involves hydrochloric acid in our stomach, ascorbic acid from fruits and vegetables, and an amino acid known as cysteine from meat. Even the way we prepare our food affects iron levels. Cooking with iron utensils can increase iron content, while freezing and thawing meat might lead to some iron loss. In summary, iron's journey in our bodies is intricate and fascinating, from intake to absorption, with pivotal roles in energy production, muscle function, and cellular respiration. Striking the right balance is crucial to our health. Keep your curiosity alive and stay tuned for more enlightening tales from the world of science. Thanks for watching.